Hi, I'm Miss Claywell. We're going to do Scale 5 notes on inverse functions. So to begin, an inverse is a relationship that interchanges, and another word for interchange is, another word for interchange is switch. The input, which is x, and the output, which is what we call y, of a function. We use the notation, we put a -1 wherever we have an inverse. So for example, if I were to write the inverse of this, 3, 2 would become 2, 3. 2, 4 would become 4, 2. So I switched x and y. If I were to find the inverse of the f function, my original outputs would become my inputs. So I basically switched my x and my y. So that is what a function is. We're now going to learn how to do that algebraically, starting with linear functions. So our first step is to replace our f with a y, because remember that's the same as output. Now I switch my x and my y, and now I'm going to do whatever I need to do to isolate y. So my goal is to get y by itself. So I end up with x plus, let me write that. I originally had an f, so I need to write my inverse notation. My answer is x plus 4 over 2. So we're going to try another linear one with these same steps. So I replace my x with y. I switch my x and my y. And now I do normal operations to isolate my y. And now I go back, I started with a g, so now I have my g of x equals x minus 4 over 3. We're now going to talk about doing this with a cube root or power function, so I'm going to follow my same steps. Now I replace x with y and y with x, but now I need to think about what do I need to do to get my x or my y by itself. So this is where it becomes a little bit more tricky. What I need to do is I need to take the cube, I need to cube both sides, because ultimately that is what's going to get rid of my cube root. So if I have a cube root, then I need to cube both sides. If I had a square root, I need to square both sides. And I started with an f, so my notation is going to be f of x equals x to the third over 2. We're going to try another one with a same idea. So this idea, you need to do it. You have to think what, so I'm kind of thinking ahead. The opposite of cubing is something is cube rooting. Now I need to switch my x and my y. Now I need to do whatever I need to do to get my y by itself. The next step would be to get rid of that cube. So I'm gonna cube root. I'm sorry, it looks so messy. So I'd have cube root of x plus 2 equals 3. Now I go back to my inverse notation. So this idea that cube and cube root are opposite operations, squaring and square root are opposite operations. So now we have an x in the denominator. So first step is to rewrite it with a y. I'm going to keep my -2 in the denominator because that's easier for me. Switching my x and my y. Now I need to think about what do I need to do to get its y by itself. So I'm going to multiply both sides by y. That way my y is no longer in the denominator. I still want my y by itself, so I need to divide everything by an x. And that ends up placing the x in the denominator there. So the next thing we are going to work on is graphing the inverse. So we've done it algebraically, but we haven't done it graphically. So it wants us to pick 5 points. So I'm going to go ahead and pick 5 points. To me, it's easiest to then mark them over here. So I have 9, -4. I think it responds to circles better. 7, -3, 5, -2. 3, -1, and 1, 0. So if I were to make the inverse of that, I would switch my x and my y. And then I'd plot those inverse points. So I have -4, 9. You guys will be able to actually do this on Delta Math. -3. Oh, that last spot was wrong actually. That was at -3. So I think you guys are getting the gist. -4, 9. 3, 7, 2, 5. -1, 3, 0, 1. And then it will automatically graph it for you. So please forgive my awful line. But it will look something like that. So that is how we graph the inverse. Sometimes you may get ones that are quadratics. So I'm still going to go with this same concept. So that's 4, 1. I have 0, 3, and 0, -1. And then it also seems to cross at -6, 4, and -6, -2. So those may not be perfect. And then I'm going to switch those to make my inverse. So I have 1, 4, 3, 0. Oh, 3, 0, negative. Oh, took away my 1, 4. 4, -6. So once again, your guys's would just be little dots, but it would look something like that. So basically, you take the original, find points, inverse the points, and then that allows them to become the inverse function. The last thing we're going to use composition, or the last thing we're going to do with inverses is proving inverses. So we learned compositions of functions last class, where you put a function inside of another function. So we have two on this slide, two important things that I would take notes with. If functions are inverses and you put them inside of each other, you will get out just an x. If you get out anything other than x, they're not inverses. So if you compose two functions and your output is an x, they are inverses. So it wants us to verify that these two functions are inverses. So I'm going to see what that equals. Actually, I'm going to explain it a different way. So I'm going to start with my f function. And wherever I see an x, I'm going to put in my inverse function. If I distribute my I end up with x plus 4 minus 4, which equals x. So they would be inverses, and I proved that. I could also start with my inverse function and wherever I have x, I put my original function. After I distribute my 1/4, I made a mistake there. I also have an output of an x. So basically, moral of the story, when you compose two functions, if they are inverses, you will get out an x. And we got out an x there as well. So I understand it looks messy. This is the last problem. We have the same situation here where it wants us to compose and figure out if they're inverses. So I'm going to start with my f function, and into it I'm going to put my inverse. So I distributed my -2/7. And while it may look like it's going to simplify to an x, it's actually -x plus 24. So I would have to say that these are not inverse functions. So you'd say f of x are not inverses, since when we compose them, they do not equal, oops, I'm going to rewrite that. Since when we compose them, they do not equal 0. Or it does not equal x. And we can see that there. Thank you guys for watching my video. I'm also seeing that you guys may be confused because part of this got cut off. So I'm going to rewrite what that was supposed to have. There we go. Hope this helps.